A triangle is a closed, three-sided geometric polygon. It functions as a rigid structural system, bound by absolute mathematical laws. The core foundational axiom of this shape is revealed when the three interior angles are measured. No matter how the triangle is drawn, these angles will mathematically sum to exactly 180 degrees. This rigid constraint allows for a dual-axis taxonomic system. We can classify every triangle in existence by its physical side lengths or by the specific measurements of its internal angles. Understanding these two independent frameworks reveals the strict mathematical matrix that governs all triangular structures. We begin with classification by sides. In this framework, the symmetry of the physical borders dictates the internal geometry. An isosceles triangle is a structure where exactly two sides are of equal length. Here, side AB and side AC share the same measurement. Because these two sides are equal, angle B and angle C located directly opposite them are mathematically identical. The equilateral triangle is a variation where all three sides, PQ, QR, and RP, are perfectly equal in length. Because all three sides match, all three internal angles must match. Dividing the 180-degree limit by 3 forces every equilateral angle to be exactly 60 degrees. A scalene triangle is an asymmetrical structure. It contains three sides of different lengths, with 0 sides equal to one another. This lack of physical symmetry guarantees that angle A, angle B, and angle C will possess entirely different numerical values. A triangle's physical borders dictate the absolute symmetry, or the complete asymmetry, of its internal corners. The second taxonomic framework involves classifying shapes by the limits of their internal angles, using the 90-degree threshold as a marker. In an acute-angled triangle, every interior angle measures less than 90 degrees. Here, 75, 60, and 45 degrees remain below that limit. An obtuse-angled triangle contains exactly one angle that expands beyond 90 degrees. As this 120-degree angle grows, the remaining two angles must compress to stay within the 180-degree limit. A right-angle triangle is defined by the presence of exactly one perfect 90-degree angle, marked here by the square symbol. The side situated directly across from this 90-degree angle is the hypotenuse. The hypotenuse is always the longest side. Because the 90-degree angle consumes exactly half of the triangle's mathematical limit, the opposite side must stretch the furthest to close the shape. The proximity of a single angle to the 90-degree mark dictates the physical span and the identity of the entire structure. We can now synthesize these side-based and angle-based classifications into one unified system. This matrix compares equilateral, isosceles, and scaling properties against acute, right, and obtuse classifications. The first immutable rule is the angle sum property. Interior angles always sum to exactly 180 degrees. Rule 2, symmetrical sides perpetually lock in mathematically equal opposite angles. Rule 3, the hypotenuse is always the longest side, found opposite the 90-degree right angle. Mastery of these three rules allows for the reverse engineering of any triangular polygon. We will now execute a verification protocol to test the application of these rules. Question 1, what is a triangle with three unequal sides? Scaling. Question 2, name the triangle with three 60-degree angles, equilateral. Question 3, identify the longest side of a right triangle, hypotenuse. Question 4, if two sides match, what is the status of the opposite angles? They are equal. Question 5, classify a triangle with 120, 35, and 25-degree angles, obtuse. Question 6, can a triangle contain two 90-degree angles? No. Question 7, classify 75, 60, and 45-degree angles, acute.
Question 8. What is the interior sum of a scalene triangle? 180 degrees. Question 9. Identify a shape with 5 centimeters, 5 centimeters, and 8 centimeter sides. Isosceles. Question 10. What angle is required for an equilateral triangle? 60 degrees. The protocol now shifts to a multiple choice framework. Question 1. Which classification has 0 equal sides? Scalene. Question 2. What is the measurement of the angle opposite the hypotenuse? 90 degrees. Question 3. All three sides match. Classify it. Equilateral. Question 4. What are the boundaries of an obtuse angle? Between 90 and 180 degrees. Question 5. How many equal sides are in an isosceles triangle? 2. Rapid deduction of these properties confirms a mastery of the fundamental geometric matrix. A triangle's identity is defined by inescapable internal constraints. You can decode any triangle by observing its borders, for scaling, isosceles, or equilateral traits, and its corners, for acute, right, or obtuse properties. Physical proportions and side lengths may drastically change, but the three internal angles will relentlessly maintain a perfect 180-degree equilibrium. Geometry provides the rigorous mapping of these absolute mathematical laws of space.